Hi everyone, this is Srinivas here. Today is the day one of understanding LangGraph. What we are going to do is try to understand LangGraph from documentation um, in a very easy and simple way. We are going to document this understanding in a video format and then put it out there just that anyone who wants to learn can also learn it from my understanding. So what is LangGraph, right? Why are we starting with LangGraph? LangGraph is the go-to framework for all agentic AI solutions, and that's what we want to learn. So what is LangGraph? Think of LangGraph as nothing but a flowchart to handle a complex AI workflows. Right? All of us are aware of different orchestration tools. I want to call in any orchestration tool like an Airflow or a Tidal or that handles different complex scenarios. When we go on and look at a typical job that happens in many of our workflow scenarios is we get the job, pull it from the source, right, apply some data quality on top of it, and then process it, and then again apply some data quality to make sure we deliver quality data to the downstreams. So this is what a typical workflow looks like. It's a DI, stands for data ingestion job, followed by a data quality job. Again, my transformations with business rules. That's a data processing job. Again, a data quality job. So the idea is to think, what if we automate or agentify the entire process of L2 ops or L3 ops? What will happen, right? What does an L2 team do? What does an L3 team do? They look at the errors, they try to find out what the errors are, and based on that they try to work on it. So that's what we want to do. So if going by the same structure, if we are able to build a lang flow or basically a flow with LangGraph that basically identifies what is my error, identify the error and send it to a specific agent like a DI agent or a DQ agent, or a DP agent to identify the error. Each of the agent works on its own errors, tries the next step that it needs to do. We have basically automated the entire L2 ops or an L3 ops scenario. So here's the overall graph representation of what we want to do. Um, let me bring that up. Okay, so here's my start node, right? The problem starts here with the router node getting the actual job name. Based on the job name, the router is intelligent enough to divide it between DI, DP, and DQ nodes, or to send it directly to the dummy node in case of false errors. And then all of these nodes converge onto the dummy node, and the process ends. So basically, this entire thing has been coded in a very simple format. The first and foremost thing that's important in while defining any lang graph application is the state. The state is a set of data structure that's consistent and that's passed across nodes, right? So when my router gets a set of variables which it can access. It updates a set of variables, and then the same set of variables are available for my next node. Can be a DI node or a DP node or a DQ node, to access it, to access the information that has been previously set by the router node. So that common data structure is called a state. It has certain key names, in this case like job name, whether each nodes have been accessed or not. Right, what we are going to do today is, since it's the first one, we're keeping the functions very simple. Each of my nodes have nothing critical in them. They just have a print statement, right? And we are just defining the DI, DP, and DQ nodes. So, and then this router out is a function that acts as a conditional edge. So what does essentially is a conditional edge is, depending on the condition, it defines which node should be the next node, whether it should be the DI or a DP or a DQ node. So the router basically understands, right, where the next node should go, where the job should be next taken into. So the logic for that is very simple. If the job name contains DI, go to DI node. If the job name contains DP, go to DP node. If the job name contains DQ, go to DQ node. We're building the graph as we have defined it here. It starts off moves to a router node, which defines and understands the job name, takes in the job name, understand where it needs to go, routes it to an appropriate node. Once that is done, these nodes then move over to a dummy node, and then the end dummy node moves over to a end node, right? And then we invoke the graph. These are all implemented as a runnable protocol. So these are runnable sequences that we can just invoke. So within at the bottom, we can see just I'm invoking with a sample DI job. So basically what we expect is the data to go in from start to the router node to the DI node and then to end. So running this simple process, as we can see here, the router, the data ingestion node, and the dummy node. So what we have also done is what we want to make sure that we have tested all the scenarios within the process. So we have written a simple unit test using the unit test framework available within Python. It contains all the DI, DP, and DQ, and others. So this goes into the DI, DQ nodes. As we can see, if I run this, it's going to take steps into each node. So data quality node, DI node, DP node, all the specific areas that we wanted to cover as part of the different nodes as part of this LangGraph. So that's a very simple code walkthrough on how we achieve this. This code is available on the GitHub. The description of the link of the GitHub is mentioned in the description. So what did we learn today? We learned that the state is very important to transfer information between nodes. Nodes in LangGraph are defined as functions. Edges can be straight edges like the one from start to router or from dummy to end, or they can be conditional edges that we saw from router to either DI, DP, or DQ. Right? We did test each path to make sure that this function is solid. What we're going to do next in the upcoming videos, what we're doing, the next video, what we're going to do is replace this simple function by an LLM based function, so that LLM can decide which node to go. We'll give it the information it needs, and that way we'll look at how to integrate LLM features of LLM like tool calling into these graph structures. That's it for today. Thanks a lot. Keep learning, keep watching.